Okay, so average velocity is displacement over time. And in the first 8 seconds, we found up here the displacement was 0 meters over 8 seconds. So what's the displacement? 0 meters per second. Question number 12, total distance traveled. So to get total distance traveled, you have to go up here and add them up. Because here first the object's traveling east, 6 meters, it stopped. Now west 6 meters, that's 12. Then it keeps going west for another 8 meters, that's 20, stops. 8 meters east, that's 28. Then another 8 meters east, that's 36. It stopped, and then it travels back 8 meters, so west, 44 meters. So the total distance traveled, 44 meters. What's its total displacement? Well, it ends up back where it started. So its total displacement is 0 meters. So the average velocity in the first 10 seconds. How far did it travel in 10 seconds? That's right here. So displacement, what's its displacement? It's 8 meters west, right? It went 6 meters east, it stopped 6 meters west, and then another 8 meters west. So it went east, it went west, and then it went further west. So this 6 meters and this 6 meters cancel each other out, and so its displacement is 6 meters west. So, or excuse me, 8 meters west. So it wants to know average velocity, which is displacement over time. And so 8 meters west over 10 seconds. And so it'll be 0.8 meters per second west. Average speed, distance over time. And so you have to add up that 6 meters, and that 8 meters, and you get 20 meters over 10 seconds. So the average speed is 2 meters per second. Okay, so what you need to be careful of is whenever it asks you for speed or velocity at a time, that's the slope. But when it asks you for average speed in the first 8 seconds, in the first 10 seconds, so the average speed over a period of time, then that's displacement over time or distance over time. Okay, so that's the displacement versus time graphs. If we were in school today, I would be giving you a blank sheet, and I'll attach it, and I do have it for you for tomorrow, but and I'll attach it to the group, but it would be on velocity versus time graphs. So if you have a velocity versus time graph, the slope of that line, velocity on one side, time on the other, the slope is going to be change in v over change in t. That is acceleration, right? Delta v over delta t. The slope will be the acceleration of the object at that particular time or over that time interval. And just like for the displacement versus time, the slope is the same for the whole segment, then the acceleration must be too. The size of the slope tells us how quickly the object is changing speed. The positive and negative sign will tell us if it's speeding up or slowing down in that particular direction. And so just like with the displacement versus time graphs, we have a whole bunch of different graphs that we can take a look at. So if we look at this first one, the slope is positive and constant, and so that means that the acceleration is positive and constant, which means this object is speeding up at a constant rate, and it's traveling in a positive direction. Okay, speeding up at a constant rate and traveling in a positive direction. For the next one, the slope is negative but still constant. So if it's negative and constant, and it's still traveling in a positive direction. And the way I know that is its velocity is positive over here. If it was traveling in a negative direction, it would be below the x-axis. So it's traveling in a positive direction, but it's slowing down at a constant rate. So the acceleration is constant and negative, shown by the slope, but it's slowing down at a constant rate, but in a positive direction. And it's because it's above the x-axis. All right? And you feel free to pause this video and write these notes down if you want. This one should be easy. Are you saying it stopped? I hope not, because this is velocity this time on this side. So it's traveling at a constant velocity. Its acceleration is 0. Slope is 0, so the acceleration is 0. It's traveling at a constant but positive speed, and we know it's positive because it's above the x-axis. This one, if it was on the PowerPoint, you would see they were two different colors. This is object A, this is object B. Oh, no, I lied. This is the x-axis, and this is object B. Okay, and so what can we say? They're both traveling at constant speed, but one is traveling faster than the other because one is has a higher speed, further above the x-axis than the other. But they're both traveling in a positive direction because they're both above the x-axis. Okay, so positive constant speed, A traveling faster than B. Next one. Next one, this is the one where they're on opposite sides. So still not accelerating, traveling at a constant speed, but one is traveling in a positive direction and the other is traveling in a negative direction. So A and B, okay? But still constant speed, but opposite direction. F. Negative slope means the object is slowing down up here, and then look, it's speeding up down here. So the acceleration is negative, and it's constant. So it's traveling in a positive direction, but slowing down, slowing down, slowing down, hits 0, and now it begins to speed up in the opposite direction. Okay? So the speed is decreasing in one direction, changes direction, and speeds up the other way. The acceleration is constant and negative. This could be, again, throwing a ball up in the air, right? So I give it some initial velocity, but as it goes up, it slows down, it slows down, it slows down. When it gets to the highest point, it stops, and then it speeds up on its way back down. One last one. Slope is not constant, which means acceleration is not constant. Slope is getting bigger, though, so it's on the positive side of the x-axis, so it means that its velocity is increasing, but not at a constant rate, and it's increasing in the positive direction. Okay? A couple of other little notes about velocity versus time graphs. How do we find a velocity at a particular time? This time it's easy. If it's like 2 seconds or if it's 4 seconds, you just go up, hit the line, go across, and read it off. So what's the velocity at 2 seconds? Go up, hit the line, go over. This is its velocity over here. How do you find the average velocity and the average speed? Exactly the same way as we did on the displacement versus time graphs. Find the displacement, find the distance, and do the average velocity and the average speed. What's different is how do we get the displacement and how do we get the distance. So how we get it, distance, find the area under the graph and then add up all the areas. Displacement, find the area under the graph, but you have to look after directions. So here's a graph, and let's say this is, 5 seconds, and this is 10 seconds, and I ask you for the distance traveled in 5 seconds. You would divide this shape up into 2 triangles and a rectangle, and you would find the area. For a rectangle, for a triangle, it's 1/2 base times height, rectangle, base times height, 1/2 base times height. All of these would be going east. If you needed to do it for the whole thing, these are trapezoids, divide your trapezoid again up, find the shapes. Add this side up, it will all be in the east direction, or the positive direction. Add this side up, it will all be in the west direction. If it asked you for distance, you wouldn't worry about the directions, you would just add these together. If it asked you for displacement, you would need to subtract these. Okay, once you have your distance and displacement, then you would go back and you could find your average speed and average velocity by using these equations. Okay, so I'd like you to now try the back side of that graph that you have, the displacement versus time graph. Okay, I'd like you to try this back side, and we will go over it tomorrow, and we will answer any issues on the velocity versus time graph. And not to worry, then I'll have another graph for you. Okay? Thanks. Have a good day.